This is Professor White. Today we are going to look at the graph of cosecant. Watch this video after you watch sine and cosine at a minimum. The first one after sine and cosine is tangents. Now I'm going to do the cosecant, which happens to be 1 over sine. So cosecant is easier to draw, the basic cosecant, if you think of your sine function first. So at a minimum, watch your sine function video first. Okay, so let's look at cosecant. The way to do that is just remember what sine look like. I know that the sine has a period of 2 pi. It goes from 1 to -1. And it makes nice sinusoidal, wiggle. It is 0 here, 0 here, and 0 here. And then it does this beautiful sine curve. All right? My drawing is not very good. It's supposed to be symmetric. This one looks a little bit too fat at the bottom. But that's besides the point. When you draw the cosecant, 1 over sine, so let me do that in cosecant x. Sometimes you'll see it as SCX. Just memorize that. I know that it's going to blow up where the sine is 0, so you're going to have those beautiful asymptotes at those points. Since only it's 1 over, it's going to keep the sign the same. And so what it's going to do, it's going to blow up at 0, pi, and 2 pi. It's going to be positive, and it's going to be touching this sign because it's at 1. 1 over 1 is 1. 1 over -1 is -1. So here's your basic cosecant graph, the blue one. So it is always helpful to draw your sine and then the cosecant, just kind of at the tail end of the sine function. Now, what happens when I try to draw -2 cosecant 2 x minus pi plus 1? So I try to put in all these different shifts and translations. So always remember, let's start with this phase shift. This guy is going to the number in front of the parenthesis is going to change your period. Your period was just like your sine period. It used to be 2 pi. And what you need to do is you need to go and divide that by that number. And so your cosecant is going to be squished. Okay, what will this number do? So this is phase shift. This number is going to make it elongate that way. In other words, remember how your sine works. If your sine jumps in there, so that means your cosecant is going to be far away from itself. This u and this u is going to be further away. It's going to be stretched. What this is going to do, it's going to, so this is the stretching. This is the phase, this is the period change, and this is the phase shift. So what it's going to do is it's going to move it right by pi, and what this is, it's going to move up and down. So in this case, move up, and what this will do, this is going to reflect it along the x-axis. Okay, you can actually look at what it does. It's just at different steps. So let's start with the period change. Now my new period is simply going to be pi. All right, so let's draw y equals cosecant of 2x. So here's my pi. Here's my pi over 2. So that means I'm going to have a kind of a squished version of my cosecant. And here's 1, here's -1. So what it's going to do is it's going to go and do this. Here's the picture of cosecant of 2x. Now, what will this do? So kind of think about it. What will this do? Phase shift. Y equals cosecant 2x minus pi. What it will do is it's going to shift this whole thing to the right. Okay, so you have a new period of pi. It's going to move everything to the right by pi. So pi plus pi, that's 2 pi. Okay, so what it's going to do is, now what was this? So how do I know what will happen to this guy? It's going to go right here. So this used to be pi over 2. It's going to move to the right by pi. So that's going to be 3 pi over 2. So it's going to be right here, 3 pi over 2. Well, and that's going to be an asymptote. So let's do that in red. 1, -1. Move everything to the right. Here we go. This is the picture of cosecant 2x minus pi. Okay, now that I got that, so let's see what happens to when I put this -2 in front of it. Cosecant 2x minus pi. So it used to be here. So it's going to go from pi to 2 pi. And the middle is 3 pi over 2. Okay? And what will happen to it? You're going to go and you're going to multiply by 2. In other words, this is going to move up to 2. This is going to move down to 2. Okay? But what will happen is, so this will move up to 2, this move down -2, but it's going to be reversed. So when you look at that, 1, 2, so it's going to be reversed. In other words, this is at -2, this is at +2. It's going to do this. Oops. It's kind of a bad location. Here we go. And this is going to move it up. Does it make sense? So it's going to start at 2, all right, and then move up, and then this is at -2, move down. What is the very last thing you do? What was the original that I wanted? +1. Okay, so how does the +1 portion is going to, work? So I have pi to 2 pi, and this is 3 pi over 2. So this used to be, so the asymptotes are going to stay where they are, but these guys are going to move. So -2 is going to move up to -1. And this thing was at 2, that's going to move up to 3. So it will look some like this. So this is the picture of y equals -2 cosecant 2 x minus pi plus 1. So if you do it one step at a time, I think you can keep out of trouble.